Okay, so picture this. You're sitting on the ground, completely still, trying to look as non-threatening as possible.
While a squirrel is sitting there judging you from across the lawn.
That is literally what we did for this lab. And honestly, it was kind of incredible.
Let's walk. We're studying eastern gray squirrels, Sciurus carolinensis. And our big question was, does the day of the week actually change squirrel behavior?
It sounds a little crazy at first. Like, do squirrels even know it's Tuesday?
They don't. But here's the thing. The day of the week changes us, how we behave. How many people are on campus? How much foot traffic is cutting through the campus? How much food waste is around?
And we hypothesized that all activity would impact squirrel behavior. Imagine a large person just towering above you. That would be kind of scary, right? Specifically, we predicted that on busier weekdays, squirrels would be more vigilant and less focused on foraging.
Our null hypothesis. None of that really matters. The squirrels run on their own clocks, driven by light and temperature, not by human nature. Not by whether it's Monday, Saturday, Friday, or Tuesday.
To test this, we used class-wide observational data collected across the whole semester, 10 long weeks. Every week, each of us went to a designated spot, sat quietly for 5 minutes, and let the squirrels do their thing.
And then for the next 5 minutes, every 20 seconds, we recorded exactly what the squirrels were doing. Foraging, alert feeding, vigilance, social behavior, all of it.
We pulled all of this into one big data set spanning multiple locations and weeks, and then we ran a chi-square test to see if the behavior proportions differed significantly across the days of the week.
And the answer was a resounding yes. And according to my calculations, we got a p-value of 2.02924.
Let's just say
we got a p-value of less than 2.02 times 10 to the negative 16th power.
So what did it actually look like? Here's our stack bar plot.
As the week progresses, vigilance increases, alert feeding drops off, and foraging shows this interesting pattern where it dips midweek and then starts climbing back toward the weekend, begin to behave reserved in their behavior and are waiting for something to happen from a distance while foraging, but not eating in a visible location.
And the heat map really drives it home. Looking at our heat map, a few things really stand out. Monday through Wednesday, squirrels are less vigilant than we expect. But come Thursday, that flips around. Vigilance shoots up and stays elevated throughout the weekend. Interestingly, the weekends are actually the least deviant from expected behavior overall, which is surprising since we predicted more socialization when campus quiets down. And foraging tells its own story. It really climbs steadily through the week, peaks around Thursday with a spike in alert feeding, and then drops off sharply heading into the weekend.
But how does that track with what we expect if human activity is the driver? Weekdays on a college campus are chaotic.
Yes, but an Engelhardt et al. 2011 paper found that repeated human exposure decreases flight initiation distance in these same squirrels, meaning they become more tolerant of humans over time. This supports our results, that squirrels on the GT campus appear to be conditioned towards human activity, and they show lower vigilance on busy weekdays, and they show higher vigilance on quieter weekends when human presence drops and the anti-predator response kicks back in.
This connects to a broader concept in behavioral ecology called the landscape of fear. The idea that prey animals are constantly balancing the need to eat against the risk of predation or disturbance. For urban wildlife, humans are a big part of that equation.
And this isn't just about squirrels. What we're really studying is how urban wildlife adapts to the rhythms of human life. And that has real implications for how we design and manage cities.
Our findings connect to 3 United Nations Sustainable Developmental Goals. First, SDG 11, Sustainable Cities and Communities. Understanding how wildlife like squirrels respond to human foot traffic can directly inform how urban green spaces like the ones on our campus are designed and when they are best left undisturbed.
Second, SDG 15, Life on Land. Urban squirrels are part of a larger ecosystem. They disperse seeds, compete with other species, and exist within larger food webs that include hawks, foxes, cats, and other urban predators. Protecting their behavioral health is part of protecting biodiversity in cities.
SDG 3, Good Health and Well-Being. Access to functioning urban green spaces, ones where wildlife actually behaves naturally, is tied to mental health outcomes for humans who use those spaces too. So when we protect the squirrel's ability to forage freely, we're also protecting what makes the green space worth visiting.
Future studies could look at whether this pattern holds across seasons or compare campuses with different levels of green space. Does a squirrel at a denser urban school behave differently than one at a campus like ours?